Hello again. Let's talk about moments. Alright. Moments. Mo. Maybe we should zoom in a little. Moments. Oh god, my handwriting. Moments. Moments. What are moments? So I'm going to give you a formula. You may or may not recognize it. Equals to R cross F. They're both vectors. And why am I talking about moments? Well, I'd want to give you an application of the cross product, and also this is an engineering principle, so this this fits this fits me, I guess. All right. What is a moment? Moments. I like to think about it. I like to think of it as torque. You may or may not have heard about it in your physics class. Torque. What is torque? Okay. What is torque? Torque is again torque is F, the magnitude of the vector F, times the magnitude of the the distance between the axis of rotation and the force, and sine theta. I think I think torque and well, that's how you express it in pre-calculus physics class, maybe around 10th grade. So I'm not going to be referring moments as torque. Probably not. Might get it confused, but let's give a conceptual view to what a moment is. Alright, what is a moment? Let's draw a bar. No, let's draw a lever. Let's draw a lever. Let's say it's straight up. This is a lever, and we apply a force this way. Force the vector F. Maybe a different color might be appealing. Let's choose this color. This is vector F. This is vector F, and in this case, the axis of rotation, I guess, or the point of rotation is this point. So R is this. R is this. Almost there. That's R. So how do we take the moment? Well, hopefully you know what the cross product is. I have a couple of videos about cross product, but essentially the moment is equal to R cross F. R cross F in that order. So how do we take R cross F? Of course, you can take the magnitude and use the right hand rule, but let's try to use the determinant way, I guess. Let's use the determinant way and find the find the direction later with the right hand rule. So first thing on our agenda, I guess, is to move the force vector such that we can connect the heads and the heads of the vectors. The heads are, is it tail or head? But the head, I'm going to be referring this as the tail. This is the head. The arrow is the head. Alright. So let's move it so that each of the vector's tails uh, touches each other. So that's F. Alright, let's take the determinant. So now, this is angle theta. And this is angle theta too. Nothing different there. So M again is equal to the determinant of the components. Let's assume it's in a two-dimensional plane. R R has components of x1 and y1, and F has components of x2 and y2. So M, the moment, is equal to y1, no, my bad, x1 times y2 minus y1 times x2. Now you might be asking me, hey, where is the direction? Where is the direction of the moment? Well, to answer that, I guess we can take our right hand and use the right hand rule. So point our fingers towards the arrow of the R vector and curl your fingers such that the vector R closes its gap with vector F. So in this case, the vector would be pointing towards the screen, or yeah, pointing towards the screen, Yeah, I'm not wrong there. Pointing towards the screen. This is point towards the screen. And this symbol is point towards you. Alright. So it's pointing towards the screen. That means it's perpendicular to both R hat and, oh my bad, R, sorry, just confused there. The vector R and vector F. It's perpendicular to both vector R and vector F, and this is a moment, right? So its direction shouldn't be perpendicular, since a moment is like a torque where there is rotation. So what's the big idea here? So vectors don't just uh, just give you the direction of its vector. It could also represent the direction in which a certain thing would rotate, whether it's clockwise or counterclockwise. In this case, it seems like it's clockwise based on your right hand rule. Again, it seems like counterclockwise. Look, even if you just look at the lever, look at it, it seems like it's going to rotate counterclockwise. But in other examples, maybe there are some examples where you won't be able to determine the rotation right away. So what you do is use the right hand rule, and whenever you curl your finger, it indicates the the way of the rotation, whether it's clockwise or counterclockwise. So in this case, my thumb is going to be pointing towards the screen, and my fingers are going to curl counter clock. Oh no, my fingers are going to curl clockwise. My bad. So just to double check. Yep, clockwise. So the direction of M, the direction of M is clockwise.